All right, guys, we are starting with our lesson today, which is on 3.2. We are going to solve quadratic equations by graphing. So the essential standard is I understand quadratic functions, that's what we've been learning about, and given a graph of a quadratic function, I can identify axis of symmetry, vertex, intercepts, and the direction of opening, okay? That was the same essential standard from yesterday. And then given a quadratic equation, I can graph with labels and scales and the function with all of its key features. Same essential standard from yesterday. So a quadratic equation, I'm going to just highlight that word, equation, is a quadratic function. Those are two different things. We'll talk about that for just a minute. That has been set equal to 0. So we've been working with quadratic functions. So f of x equals ax squared plus bx plus c. Now we're going to create a quadratic equation, which is an equality. An equation has to have an equal sign. And so essentially, we're going to take that function and set it equal to 0. So it has a standard form of ax squared plus bx plus c equals 0. Now we have created an equation. We have an equal sign in it. And we only have x values. We have set the y value equal to 0. And notice we have to have a not equal to 0. If a is equal to 0, it no longer becomes a quadratic relationship. The square term goes away. Now b can be 0, c can be 0. Okay, but a cannot be 0, otherwise it's not a quadratic. The solutions to a quadratic equation are called the roots. Roots are called zeros. Let's think about that for a minute. What does that mean? Look at that quadratic equation. What does it mean to have a solution? You find the x values such that the output is 0. So all of the x values such that the y is 0 are the solutions. Where does that y, when y equals 0, what are we doing? We're actually crossing the x-axis. So that is the x-intercepts on the graph of that corresponding quadratic function. So we can have several different situations, right? Because our function can move, right? We can shift left, up, down, translate or dilate it vertically, horizontally, as well as have a reflection. So let's take a look at this first situation. I only have one real solution. I only have one value of x such that the quadratic equation is equal to 0, and that is an x-intercept. So that value of x, if I were to plug it into the equation for that quadratic, I would get an output of 0. And then I have the option to have two real solutions. Since this is a parabola, that is a shape of a quadratic function, I can have it cross the x-axis twice. Now I have two values of x such that my output is 0, or two x-intercepts. Remember, those are called roots or zeros. But I could also shift this quadratic function upwards, right? Or maybe even downwards into the third or fourth quadrant, and it doesn't have to intersect the x-axis. In that situation, I have no solutions. There are no values of x such that the output of the quadratic equation is equal to 0, okay? So here we go. We're going to do some examples. We have the instructions say use the related graph of each equation to determine its solutions. So I have in A, the quadratic equation, which is x squared minus 3x minus 4 is equal to 0. I have been asked to find the solution. So I have an equation. How do I know that? Because I have an equal sign. What values of x, if I were to plug it into that quadratic equation, would give me 0. That is the x-intercepts, okay? And this particular problem, it crosses the x-axis twice. And so the answer in this situation is x is equal to -1 or 4. I have two values of x that give me an output of 0, okay? All right, B, how about you try one yourself? All right, welcome back. Once again, I have two values of x that give me an output of 0 if I were to plug it into the equation minus 0.5x squared plus 5x minus 12 equals 0. Those values are 4, 6. That is my answer. Okay, this particular problem in C, x squared minus 6x plus 9 only has one location, and it happens to be at the vertex. So at any rate, x is equal to 3. So I have one solution. And then the last one, why don't you try that one? Welcome back. So this particular quadratic function does not intersect the x-axis. There is no values of x that will meet this equality. There's nothing I can do, no value. So this has no solution. Okay. Okay. Now, we need to learn how to use our graphing calculator. In my lesson for today, I have also included these worked out in the TI-84 screen, so you can go and look at that directly if this is hard to follow. Your graphing calculator can also be used to solve equations. These functions are in the calculate menu on the trace key. A second function, trace, will get you to calculate. Both the 0 and the intersect, which I'm going to show you which one to use when, can be used to solve equations. Now, once again, your calculator is not the brightest. It needs your help to find these solutions. You must answer 3 questions to assist it. Okay, that left, right bound, or which curve are you asking for? And then you have to then guess. Remember, your calculator's lazy, and so it wants you to give it some idea where to start, and eventually it will quit, even though it thinks it found the exact number. It might only go to a certain number of decimal places, okay? 4 to 5 decimal places. So here we go. So there's 2 approaches to this. First is to find the zeros. This works well when everything is on one side of the equation. The equation is equal to 0. So what that would look like is ax squared plus bx plus c is equal to 0. Okay, so you would basically rearrange the equation if it was not already done so, to have it in the standard form, and then you could use this approach to find, what are we trying to find? We're trying to find our roots or our zeros, such that when x is whatever that value is, the output would be 0. Okay, so remember, we're going to have to specify a left bound, a right bound, and guess. So let's see what we would do. Okay, so solve the quadratic equation with your graphing calculator. We have 2x squared plus 5x minus 3 is equal to 0. And so we would go into y equals, and we would enter in 2x squared plus 5x minus 3. Don't forget that this key right here is how we enter in x. And then once we have entered in our equation, we don't have to enter in 0. All it is 2, because it'll just say y1, right? It would say y1. And then you would just basically type in 2x squared plus 5x minus 3. Then you would go to calculate, which how you would get there is second function trace, and you can see the calculate is above trace. That gets me to, that's what the second function does. And I would see this menu right here. And because I'm trying to find values of x that give me my zeros or my roots, I would choose the second option. And then I could see this graph right here, okay? And so how would I do that? Now I'm being asked to answer some questions. I'm asking left, right, guess. Well, you'll notice that I actually have 2 values where it crosses the x-axis, so I actually have to do this twice. So I would have to either using enter in, so this one right here just guessed at my, set the left bound at -5, or you remember you can use the trace key to scoot over to get to the left of that. Then I need to be somewhere on the right side, and that would be on this screen, and this was entered. You could enter it in, or you could use the arrow keys to get you over to the right side of that. And then you have to guess. So you need to either guess that value, okay, -2 is what was entered, or put the trace key right at that intersection and hit enter, and sure enough, it gives me x equals -3. At -3, if you plug it into that equation, you would get an output of 0, okay? That is one of the roots or the zeros. You would then have to go through the same process again. You would hit second function calculate and start it all over and hit left, right, guess, but this time we're going to be focusing on the second 0, and so you would have to get left, right, and then guess. And this would give you an output of x equals 0.5. So the answer, I don't know why I changed colors on us. The answer would be x is equal to minus 3 comma 0.5. So these are my zeros or my roots of that particular quadratic equation. All right, why don't you try this one? Okay, and notice this instructions, because this one's going to give you a decimal, will give you accurate to 3 decimal places. Okay, welcome back. Hopefully you were able to find your roots, comma, minus 1.828. If you had trouble with that, you can look at my calculator help video, which I walk through each one of these, and you can see my screen. Now, we have one more thing to learn. We can use intersection, the intersect option on our calculate screen to solve if neither side of the equation equals 0. So let me show you an example of that. Right here, this example 3x squared plus 8x, and then we have equals 1 minus 2x. Now you could move everything over to the left-hand side and get it in standard form, but you don't have to. You could quickly solve this using the intersect, and I'll show you how. So what we're going to do is we're going to go once again into y equals, and we're going to enter this part of the equation into y1, and then this part of the equation into y2. So you would have y1 equals 3x squared plus 8x, and y2 is equal to 1 minus 2x. Now I have 2 equations. And then what we're going to do is we're going to go again to second function trace, which will get me to the calculate option, which will give me this screen right here. And we're going to actually find where those 2 curves intersect. Okay, where does the values of x, where are the values of x such that those 2 equations are equal to one another? That occurs when they intersect. Okay, and so this is the screen that we're going to see right here. And I have 2 curves. Okay, instead of left, right, guess, we have to make sure we have selected the correct curves to ensure that it's looking for the intersection of the curves that you want. We only have entered in 2, so it knows that there's only 2 curves. But what if you had 10 equations in there? Which intersection, which curve are you asking for? So it'll say first curve, and it will be highlighted on one of them. You just hit enter. The second curve, you'll be on the second one, and you can hit enter. But now you need to guess, because we actually have 2 intersections. So there's 2 values of x such that this equality is true. Okay, so we can guess it, or we can trace and kind of get right on the intersection and hit enter, and then do the same thing over again and find the second one. Okay, and I don't have written here what those answers are. Oh, actually the answers are right here. Here they are. So the first one was found at x equals 0.097, and I'll just say 2. And then the second one was entered, so this is not right. The second one was found to be x equals negative 3.43. I don't know how many decimal points he didn't say. Okay, so what is my answer to this problem? That is the x is equal to 0.0972, comma, negative 3.431, and there is my answer to the A. Now, pause the video, try using that technique to find the values of x such that that equality is true. Welcome back. The values are minus 3.236, comma, 1.236. There were 2 values of x such that that equality is true. Now notice there is a y value, there is a y, what am I trying to say? There is a y coordinate that is related to that location of that intersection. We're not interested in that. We only want to know the x coordinate that would, if I were to plug it into that equation that's given either an A or B, it would give me an output of it would set those 2 equations equal to one another. Okay. All right. I hope that makes sense. If you have questions about this or you need help, there is a second video that has step-by-step, screen by screen of how to enter those into your TI-84. Come see me if you have any questions.